University here, Kavitri Bainamai Chaudhary University, and also I am working as a Dean R&D of our institute. I will share my files. So the first basics of nanoscience or nanotechnology. I think I don't know what kind of participants are here, whether all are belonging to sciences or also engineering faculties are there. I don't know. So, but I think now these days, this nanotechnology and nanoscience is equally important for all the participants which are participated in this workshop. And definitely, I will ensure you that I will satisfy all the audience in this workshop. So I'm starting the first part of this presentation and our topic is functional nanomaterials and advancement of technology. So here, as I have splitted this in three parts, the first part will be basics of nanomaterials and nanotechnology. And this is the presentation view or layout. Uh, sir, am I audible? Okay, sir. And what about my screen? Okay, okay. Okay, now is it visible now? Okay, sir. So the presentation layout is introduction, then what is nanotechnology, why nanoscale is there required, then what is the nanomaterials that we have to. Yeah, I have selected it. Sir, I have selected it. Okay. Then we'll see nanomaterials and the characteristics, or we can say characterization and uh, brief history about when nano materials or nanotechnology started, then approaches of nanotechnology, bottom up or top down approaches for the synthesis or methodologies, we can say, and we'll emphasize on applications of nanotechnology. So here, as the concern is about what is nanotechnology, the design is very important. The design, then the characterization and applications of structures, devices and systems by controlled manipulation of size and shape of materials at the nanometer scale is required. And the manipulation is at the level of atomic level, molecular level, and micromolecular scales. So here, to produce materials with at least one novel superior characteristic or property is very important to explore that material for the technical purpose. So this is we call in brief as a nanotechnology because we get materials in different forms at the nanoscale. Yes, sir. Sir, it is in presentation mode. Okay, so I don't know why. हो, स्लाइड शो वरतीच मी क्लिक केलेलं आहे. बघा सर, स्लाइड शोला मी क्लिक केल्याच्या नंतर हे असं दिसतं आहे. आता कसं दिसतं तुमच्याकडे? हो, पूर्णच माझ्याकडे तर स्क्रीनवरती पूर्ण स्लाइड दिसते फुल. मला वाटतं काहीतरी कम्पॅटेबिलिटीचा प्रॉब्लेम असेल माझ्या साईडला. तुमच्याकडे इंडिव्हिज्युअली करता येत नाही का तसं? बरं. Okay. Then we'll continue with the why nanoscale is required. So now many people are familiar with this nano size properties of the materials. A nanometer size is 1,000 millionth of a meter, and people are interested in the nanoscale because at this scale, physical and chemical properties of materials differ very significantly from those at a larger scale. And also, depending on types of material, whether the material is magnetic, ferroelectric, uh, then any other kind of material, conducting material is there, then their properties also may affect significantly. Sometimes the properties of some materials may degrade also. So that can be manipulated with the help of converting that material into nanoscale. Now one can see the scale here in our day-to-day life. We can just compare the nanoscale and upper scales with the available particle sizes. We can see the atomic size here around 10 to the power minus 1 to 10 to the power 0 or around 10 to the power minus 1. So these are the scales given here to just have the idea to compare nanoscale with our various sizes in day-to-day life. Now, what is nanomaterial? It is defined as any material that has unique or novel properties due to the nanoscale or nanometer scale structuring. These are formed by incorporating or structuring of nanoparticles. That means we can transform any material into nanostructure. Now the shape may be different. There are various shapes. So they are subdivided into nanocrystals, nanopowders, and nanotubes also, and a sequence of nanoscale of C60 atoms arranged in a long, thin cylindrical structure, which is mentioned here as a CNT, carbon nanotube. In next slide. So one can see here carbon nanotubes may look like this, and we call this as up to certain length in nanometers. We consider those tubes as a nanometer tubes of carbon. And now these days, carbon nanotubes are very, very important because the properties of conductivity can be tuned. These carbon nanotubes can be filled with various materials and their conducting properties can be tuned. And therefore, there is a very much significance of these CNTs. In short, we call it as a carbon CNT as a carbon nanotubes. Now one can see here various structures at nano level. Depending on crystallinity, the materials are available in different crystal forms, and depending on that, some materials will be looking like hexagonal, some materials will be tetragonal, then cubic structures will be there. Some particles in nanoform will be like dumbbell shaped like this. You can say biconic material, isn't it? Then some will be in rod form, and depending on which method we are using, materials can be obtained in specific shapes depending on your synthesis properties and synthesis parameters. We can say the applied pressure, temperature, and the aging given to the materials, it can transform in different forms. So here we can say that noble metal nanocrystals with cyclic pentatwin structures can be obtained very nicely by using certain methods. Now this slide shows us that particles of uniform size can be obtained by certain methods, and this particle range can be in between 5 to 10 nanometers. And if suppose strictly particle sizes are remaining constant, same, almost all the particles are of same size, then we call it as the monodispersed uh, nanomaterials, nanoparticles. And such particles, if we are able to synthesize, then those are very applicable in medical field, depending on the material, what material we are synthesizing for nanoparticles. And those particles are considered or can be considered as quantum dots, as their particle size is falling below 10 nanometer. So such particles, when we take in aggregate, it look like as a nano powder. Now we'll see what is nanomaterial. Nanotubes are extremely strong mechanically and very pure conductors of electrical current. Now we are talking about that nanotube CNT. So as I mentioned there, these nanotubes are very highly conducting like metals, and their beauty is this, that they are conducting like metal, but they are very stable at high temperature, where the metals at high temperature are not that much stable. So this is beauty of these CNTs. And looking at applications of the nanotubes include resistors, capacitors, inductors, then diodes and transistors. So in these devices, now these days, CNTs are used very efficiently. Now, what is nanomaterial? Again, under the same, nanomaterials are interesting because at the small scale, materials have fundamentally different properties than at the bulk due to increased surface area to volume ratios. Now, here, this slide is little different than the routine one. Why? Because it highlights on the ratio of surface to volume of a particular particle. So if you compare different particle sizes, then we'll find that as particle size decreases, the surface to volume ratio is increasing. And this is very important for the materials, where we can get surprisingly increased or enhanced properties, specific properties, so that we can tune a particular physical properties for our application, and we can decide the material where it is more applicable and how can we tune their either electrical properties or magnetic properties or ferroelectric properties or many more. So in this way, the nanomaterial surface to volume ratio is very important. Korde sir, please give me feedback in between whether the screen is properly visible or my sound is not audible. Okay. That is in not full mode. I don't know what to do, because here I have placed that in presentation mode. So why it is not? Okay, I will try in that way also. Uh, Now space shift. No, it will not take. Only we have to press F5 and it is taking in presentation mode. But there it is not visible. It is visible to me. It is in presentation mode. See, you can see here. Sir, see my screen. Are you seeing? Hello, sir. You can see in my mobile screen, the complete screen is there. Okay. So I don't know. Okay.
Hello. Hello.
Yes. Yes. Yes, sir.
It's visible, but not in the presentation mode.
Yes. Same thing I'm
Slides
saying.
are
It is
visible,
visible
but
to me. It is in complete uh, PowerPoint mode. Okay. In slide mode. Hello, sir. I think individually also people can try and put there in full form. Okay, okay. Okay, sir. Okay. Yeah, you can't do from your side. Okay. So I will proceed. Now see, under this now I will proceed what the increased surface to volume ratio does for the technical benefit. I will highlight the increased interaction and reactivity is one of the byproducts of materials and that are nanoscale, which means potentially using less of the material, or that even on the nanoscale the properties are very different from that of the bulk scale. That means the properties are always in enhanced form and the requirement of material is very less. That is the significance of the surface to volume ratio. Now, nanomaterials characteristics, most of them are novel, and why? So, one definition of nanomaterials is mentioned here. The new forms of existing materials with characteristics that differ significantly from familiar or naturally occurring forms. Naturally also it can possible to degrade the material will degrade and come to the nanoscale. So in that sense this definition is given. Nanomaterials can have one or two or three dimensions in the nanoscale. That means nanomaterial can be available in three-dimensional form. One dimensional, we call it as a 1D material. Two dimensional, we call it as a 2D materials, 2D nanomaterials, and three dimensions means three-dimensional nanomaterials. Mostly nanoparticles are considered as three-dimensional nanoparticles. So we can say that we can convert that material into 1D, 2D, and 3D. So here uh, the materials are categorized or given in few types. So first column is types of nanomaterials and the second column is shape or form of the material. So one dimensional nanomaterials are nothing but, for example, depending on shape, layers, multi-layers, thin films, platelets, and surface coatings. Also flakes are there. Flakes are free, not fixed, but those are also surfaces, are two-dimensional, we can consider, and they have been developed and used for decades, particularly in the electronics industry. So this is significance of one-dimensional material. We can coat very nicely on some substrate materials, and we can produce that in the form of films. Second material, that is two-dimensional materials or nanomaterials, are the examples are nanowires, nanofibers are made from a variety of elements other than carbon, nanotubes, and subset of this group are carbon nanotubes. In addition to this, again, we can add many more materials. We can add rods in 3 dimensions, nanorods, we can say, or nanowires. So this is second type. And the third type is 3 dimensional nanomaterials. We are known as nanoparticles and include, uh, you can say, peptides or precipitates, colloids, and quantum dots. Quantum dot is also example of the 3 dimensional nanomaterial, though it is very tiny, around 10 nanometers diameter. It is considered as a 3 dimensional nanomaterial, and such particles shows very uh, important properties of semiconductors. And depending on which material you are degrading to form nanomaterials, that is important. So depending on the selected material, whether it is ferroelectric or magnetic or conducting, that material shows the change in that particular property. So this is regarding the types of nanomaterials and their shapes or the different forms. Now, the question is when nanotechnology started. It's not our matter, but actually, in ancient period also, nanoparticles were available, but only because of the sensors available or technology was not available. We were not able to uh, comment about that, and therefore, in some senses, nanoscience and nanotechnologies are not new. Chemists have been making polymers, which are large molecules made up of nanoscale subunits, for many decades, and nanotechnologies have been used to create the tiny features on computer chips for the past 20 years. And that is in the form of, you can say, nano chips or films, where films are nothing but also the molecules or atoms were coated in the form of a thin film, and that was also the example of nanotechnology. However, advances in the tools that now allow atoms. Yes, sir. Yes. काय सर स्लाइड दिसत नाही का? ओके ओके ओके, एक मिनिट. I have to check my whether. सर एक मिनिट, क्रोम मधूनच केलेलं आहे मी. क्रोम मधूनच केलेलं आहे. एक मिनिट, माझं बहुतेक नेटवर्क गेलेलं होतं. येस. हा. हो, गुगल ड्राईव्ह नाही सर. मी काय केलं, मी शेअर केलं, स्क्रीनवरती उघडून ठेवलेलं होतं मी. गुगल ड्राईव्ह वरती नाही सर, माझ्या स्क्रीनला, माझ्या डेस्कटॉपला आहे. मी गुगल ड्राईव्हला ठेवून देऊ का? एक मिनिट सर, मी तुमचे शेअर करून टाकतो. ओके सर, ओके, जस्ट 1 मिनिट. सर मला 1 मिनिट द्या. मी तुमच्या मेलला मी तिन्ही पाठवून देतो, ते बरं राहील. सर आता तुमच्या मेलला माझे तिन्ही प्रेझेंटेशन आलेले आहेत. कोरडे सर. हॅलो. ओके. हा सर होतोय का? हा सर आता प्रेझेंटेशन दिसतंय तुम्ही अपलोड केलेलं, शेअर केलेलं. आता तुम्ही त्याला स्लाइड शो करा. मला तर नाही दिसत इथे. सर आता दिसतं का पहा बरं. कोरडे सर. विवेक सर. हा काय झालं. एक मिनिट हा. सर आता मला काही ऍक्सेस नाही आहे त्याचा. बरं एक मिनिट हा, मी रिझ्यूम केलं आता पाहूया. एक मिनिट सर, एक मिनिट हा, आता दिसतंय का पाहूयात. पण आता फक्त आता एक मिनिट बरं. काय खरं तर असं व्हायला नाही पाहिजे. हा आता दिसतंय सर. हो आता दिसतंय. हो. काय केलं सर तुम्ही. अच्छा, गुगल ड्राईव्ह मध्ये घ्यायला पाहिजे होतं का. बरं ठीक आहे. आता मला पुढं नेता येईल का स्लाइड हे. बरंच पुढे गेलेली आहे. चला पुढे, चला पुढे, चला. अगदी शेवटच्या याच्यातल्या 4-5 स्लाइड राहिलेल्या आहेत. आणखी पुढे. अजून. हा अजून पुढे. 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 ओके. पुढे. याच्या पुढे. पुढे. ओके. थांबा सर आता. अजून एक स्लाइड पुढे. ओके. Now, please tell me everyone whether this is fully visible to you people. Okay, okay. Now, sir, we'll discuss about the approaches of nanotechnology in case of growth methods. That means how to prepare or grow the nano materials. There are two types given: bottom up and top down methods. Bottom up approaches seek to have smaller components built up into more complex assemblies, while top down approaches seek to create nanoscale devices by using larger externally controlled ones to direct their assembly. That means we can deposit thin films, or you can directly design some units in the form of nanoscale there. That is called the top-down approach. The top-down approach often uses the translational workshop or microfabrication methods wherever externally controlled tools are used to cut, mill, and shape materials into the desired shape and order. That means the patterning of material. If suppose we want to create structure, repeated structure of some squares, of suppose uh, 4 nanometer squares structures we have to put by in periodic array, we can generate like that also. So that is called the controlled top-down approach to create nano devices, and that is applicable in sensors and you can say fuel cells. Sir, पुढची slide here. Next. Then micro patterning techniques such as photolithography and inkjet printing belong to this category. These are very, very important techniques. With the help of photolithography, many nano devices and micro devices can be built in specific manner. Then bottom-up approaches, in contrast, use the chemical properties of single molecules to cause single molecule components to self-organize or self-assemble into some useful conformation, or rely on positional assembly. That means here also we can put single molecules in particular pattern, and we can execute that assembly for the nano device. Next. Next slide, sir. This is just bottom up and top down approaches are given here to just distinguish between them, how systems work for creating top down materials and bottom up materials. Mostly bottom up materials are nothing but these are deposition techniques which we can take bulk material and degrade that into molecules or particles, and uh, deposit that on some substrate in the form of thin films. So that is called bottom up approach. And the first one is top down approach, where we can degrade bulk material into nanoparticles, nanorods, or nanowires, etc. Next slide. Now we can see applications of nanotechnology. This is the general categorization of applications. The most bold fields are medicine, information and communication, heavy industry, consumer goods, and environment. So here, as we see under every head, we can see under medicine, examples are diagnostics, drug delivery, tissue engineering, cryonics, etc., cryogenics. So there are many applications under one head. Now these days we know that in case of drug delivery, if suppose we use iron nanoparticles encapsulated with certain polymers, because if you take directly these nanoparticles in our body for certain diagnosis, it is not good. it can form some poisonous materials or composites. And therefore, to avoid that, such nanomaterial, nanoparticles are encapsulated with some non-harmful polymeric materials, and those are taken for drug delivery, where with which we can deliver the drug very easily, and we can use those materials for our uh, medical field. Then next is information and communication. Now these days, because of the uh, this nanotechnology, memory storage devices are uh, very rapidly taking small forms because the storage density is very high. And because of that, now these days we know that in a very small pen drive we can store very huge data, which was not possible earlier. Then next are novel semiconductor devices, novel optoelectronic devices, displays, quantum computers. Now in quantum computers, quantum dot technology is used, and therefore now those are again becoming advanced systems. We can say next generation computers will be there with the help of quantum dots. Then heavy industry, aerospace, catalysis, construction, and vehicle manufacturing manufacturers are also using some nanomaterials to improve the their functioning in their field. Then consumer goods. In consumer goods also, foods, household, optics, textile, cosmetics, sports are also equipped with various physical properties with the materials that are available in nano form or nanomaterials. And in environmental field also, in environmental field, mostly we use the materials in nano form for fuel cells, sensors to sense the poisonous gases in air, so that we can control and monitor our environment to keep it in a good condition. So sensors are playing very important role in terms of the environmental applications, which are not mentioned here under the examples. Please next slide, sir.
रजनीकांत पाहिजे पहिले पिक्चर नाही तुम्हाला निघाले पाहिजे जिल्हा तुम्ही पहिलेच पाहिला असं
सर परत बाहेर आलं वाटतं ते पहा बरं लाईव्ह शो
ते माहिती ते पोंग्या तुम्ही आता
ते स्लाइड शोच्या बाहेर आलं परत ही संपलेली आहे का? मला वाटतं अजून 2-3
आता एक तुम्ही टाइम तुमचा फिक्स करून ठेवा अडीच नंतर मी काहीच घेणार नाही पोझिशन मध्ये जर असाल ऑलरेडी तर ठीक आहे पण स्पेशली अडीच नंतर नाही घ्यायचं कारण तिथे इतकं थंड पडते मार्केट सगळे सोडून येतात आणि जर झालंच
प्लीज समवन इज टॉकिंग इन बिटवीन प्लीज अजून दिसत नाही सर हा एक शेवटची स्लाइड राहिलेली आहे okay yes it is now visible so again in continuation with that slide and there are again some application heads here under which we have to discuss the examples. So carbon capture, under the carbon capture head there are few examples: photocatalysis, consisting of silica nanosprings coated with a combination of titanium dioxide. And this is also a very good application. Then sensors, pollutant sensors that able to detect lower limits with low cost. Where I have worked with nanomaterials also. Directly, my MPhil topic was on sensors application. Remediations, that is decontamination, oil split management. For these techniques also, for this application, also materials can be used. Heavy metal contamination removes heavy metals such as lead, cadmium, nickel, zinc, copper, manganese, and cobalt in a neutral pH environment without using any form of sulfur. So, in this way, we can use various particles in remediations also. Wastewater treatment. For wastewater treatment also, we can use nanotechnology, and we can uh, give the treatment for that water. Veolia Water Solutions and Technologies, this is company name. Ceramic membrane modules, utilization the ceramics technology platform can be supplied with a variety of inorganic microfiltration and ultrafiltration membranes. Then in energy, heat distribution, etc., ceramic like materials that provide sufficient reliability and durability of the entire structure. Now, this under energy, this application is not limited. Under energy, we can discuss many materials. Because of time, we can't. Uh, we can explore many materials as electrodes, where the electrodes are nothing but made up of nanomaterials. Some coating is there on some substrate, and those materials work very efficiently for battery applications, in fuel cells, where we can replace platinum like costly metal and use metal oxides. Also, in drinking water purification, nanoparticles are used, mostly carbon nanoparticles or carbon rods are used there in drinking purification, water purification. So these are applications, environmental applications. Sir, this part is over. Now I would like to request you that you share the next PPT. Okay. One minute. Yes. Yes, sir. Go back to first slide, sir. Yes. Now we have talked about the introductory part of the or basics of nano structures or nanomaterials and nanotechnology. Now we'll focus on methodologies, we can say synthesis methodologies or methods of synthesis in brief, so that it may be uh, this this will give brief idea to the participants about the synthesis of nanomaterials. Directly, I have taken example from my work, and I will present how to proceed with one method. I'm not discussing all the methods. I'm just putting broadly some methods and discussing one method in detail so that one can be benefited. Next slide. Yes. Methods of synthesis of nanomaterials. We can categorize broadly the physical methods and chemical methods to synthesize the nanomaterials. So under physical methods, ceramic methods, that means we can take directly the chemicals with proportion appropriate stoichiometric ratio, and we can just mix it, and physically we can go on crushing or mixing, and then finally we give treatment. That is called ceramic method. Next is the ball milling method, where there will be a machine, we can say ball miller, and some ceramic balls will be provided in which we can place our chemicals together and go on mixing with the help of balls. That is called ball milling. And sputtering methods. Sputtering methods are various methods. We can take metallic targets or metal oxide targets, and by applying high potential across the electrodes, we can deposit that material in the form of thin film. There are also sub methods of this. I'm not going into detail. Then chemical methods. Chemical methods are very easy to get nanoparticles or particles of different shape. So here under chemical methods, there are few methods mentioned here. Chemical co-precipitation method, chemical bath deposition method, which is called also CBD. Then successive ionic layer adsorption reaction, which is called CLAR. Then sol gel method, which is very famous, and most of the researchers will synthesize methods by this. And also one more famous method is autoclave method. By using autoclave method, mostly people will get particles or materials in different shapes, flower like, rod like, tubes, or some patterned materials, isn't it? So one can select appropriate method for their synthesis and go ahead. Please go to the next slide. Yeah. Now here, chemical bath deposition method is shown here. This is very simple method where two electrodes are immersed in the liquid, desired liquid. That liquid is initially, the researcher will take initial care what stoichiometry various chemicals has to be taken, and then solution is made, and then these electrode plates are immersed, and the substrates are also there, so that what will happen, this material will be starting depositing on that. So here, clinical bath deposition relies on creating a solution such that deposition will only occur on these substrates. And metal salts and chalcogenide precursors are added to water to form an aqueous solution containing the metal ions and chalcogenide ions, which will form the compound to be deposited. So after deposition, one can see in side figure, the particles are deposited very nicely, isn't it? These are the micro images. You can say SEM, scanning electron micro size images. So one can see grains here deposited uniformly in the form of thin film. Next slide. Then the controlling parameters are temperature, pH, and concentration of salts are adjusted until the solution is in supersaturated. That is, until the ions are ready to deposit. A substrate is introduced which acts as a catalyst to nucleation. That means the surface is active and nucleation will start on its surface, and the precursor ions onto the substrate, forming a thin crystalline film by one of the two methods described below. So that is, the solution is in a state where the precursor ions on colloidal particles are sticky but can't stick to each other. That means particles can't stick each other, but on substrate particles can stick. So when the substrate is introduced, the precursor ions or particles stick to it, and aqueous ions stick to solid ions, forming a solid compound depositing to form crystalline films. So in this way, by chemical bath deposition, one can deposit thin films. Please go ahead. Oh, it came out, sir, from the slideshow. Yes. Can you make me enable to bring it in slide form? Okay. Previous slide. Previous. Okay. Now next. Sir, next slide. Again next. Yes. Stop it. Yes. Yes. Now this is called Silar method, successive ionic layer deposition reaction. In brief, it is called Silar method. And there are few steps given here how to proceed. So as it is a successive ionic layer deposition, the beakers are arranged like this. That means how many chemicals are taken. Depending on that, we have to take the two separate chemicals here in alternate beakers, and in alternate two beakers, distilled water is deionized. Distilled water is taken here. So it will proceed like this for the deposition of two materials. Next slide. Now here the steps are given. Prior to the deposition, stainless steel substrate was polished with zero grade polished paper, and it was ultrasonicated in double distilled water. The solutions of 0.1 molar COCl2 and 0.2 molar Na2S prepared in distilled water or deionized distilled water were used as cationic and anionic precursors or precursor solutions respectively. The deposition was carried out at room temperature about 300 Kelvin, and it is involved with four steps. Four steps were involved in one complete Silar cycle. First is adsorption of cations. CO2 dipositive ions will be deposited and adsorbed. Then first rinsing in distilled water is taken. That means after deposition, we have to immerse that, or we have to rinse that into distilled water. And third step, adsorption of anions. The same plate can be taken to immerse in the third beaker, and cations of CO dipositive, sulfur dinegative will be deposited, and cation on the cation CO2 diposited. That means in first step, what we are doing, we are depositing CO2 dipositive ions. Then we are rinsing that to remove some impurities, or we can say some volatile species. And then in third beaker, again we are immersing the same plate. So what will happen on CO2 layer, CO2 deposit layer, sulfur dinegative ions will be deposited, and then again secondly we rinse it in the distilled water. So in this way, it is four-step method, which is called Silar method. Please, next slide. In Silar method, the time duration for adsorption, reaction, and rinsing are very important parameters. In present study, the optimized time periods for absorption of CO2 dipositive, CO dipositive, not COT, CO dipositive, absorption of anions, sulfur negative ions, and their reaction with pre-adsorbed cations, and rinsing in first and fourth beakers are uh, sorry, in second and fourth beakers, it is by mistake mentioned as a first. Second and fourth beakers are 20, 20 and 50 seconds respectively in 3 beakers. And then what will happen? The CO3 S4 films will be deposited by varying deposition cycles, as the cycles were set for 20 seconds, 40 seconds, and 60 seconds. So finally, which film will be deposited? Cobalt sulfide film will be deposited on the substrate. In this way, this is called CLR method. Please, sir, go ahead. And now we'll discuss one more method, which is very important, and in every laboratory, in any small laboratory, one can proceed to select this method for the research purpose. This is very clean and easy method. Initially, the researcher will face few problems, but after practice, he will start to synthesize materials by this method very easily. So here, the initial ingredients are taken as a AR grade materials, or metal nitrates are used for preparation of nanoparticles by Sol-Gel method, and the compositions of ferrites are calculated in terms of mole percentage. Then next, this mole percentage is then converted into weight percentage by a traditional calculation method, and these nitrates are weighed in required molar proportion using an electronic balance. Next slide. Now see here, very simple calculation is given because of the incompatibility of this mode. Some symbols came there as a question mark, so need not to worry. If suppose I am going to prepare nickel ferrite NiFe2O4, and my calculations are for, now I have to vary the ratio, atomic ratio of nickel ferrite in the given form, and then, or if I want to incorporate cobalt also in the structure, then how to proceed for the calculation, that simple method is given here. So calculations of molar weights for nickel, cobalt, iron oxide is given here, and my expected formula is nickel 0.8, cobalt 0.2, and iron 2 molecules, atoms, and oxygen 4. So this is my formula. So to proceed for this, these are the calculation methods shown here. Purposely I have taken this slide. If suppose there are some beginners to start their research, then they can be benefited with this method. Okay, so in this way we have to proceed 0.8 into molecular weight of nickel nitrate, then 0.2 plus 0.2 into molecular weight of cobalt acetate, plus 2 into molecular weight of ferric nitrate, and then I have to go for take oxygen in my formula from the environment. So the total quantity will be like this, but we can reduce it for avoiding the excess use of chemicals. Please, sir, go ahead. So with the earlier formula, I can proceed to take the 3 to 4% of each of the above ingredients, and can be taken in grams and mixed together in water to form solution for the preparation of final product, say as per mentioned there, nickel 0.8, cobalt 0.2, iron 2, and oxygen 4 atoms. So here we have to balance this. For nickel and cobalt, it should be total 1. So similarly, fractional weights of ingredients for preparation of all ferrites of the series can be recorded and mentioned. Please Go to next slide. So these are the chemicals and their chemical formula mentioned here of nitrates. One cobalt acetate is taken instead of nitrate, and their corresponding molecular weights are given. So next slide. Now there are few steps for this method. These salts then poured in a beaker to dissolve them in distilled water. Of course, in stoichiometric ratio, we are taking those. And these salts are dissolved in distilled water and a clear solution of salts was obtained. Okay, now this is our starting to proceed for sol gel method. Okay, first what we have to do, the salts, weak salts are we have to take in distilled water and dissolve it. And then after dissolving that, we have to get clear solution of salt. If suppose solution is not clear, then we have to heat the solution to make it clear. So the beaker containing this solution was kept on a magnetic stirrer for constant stirring and heating for 1 hour at 80 degrees Celsius for uniform mixing of the raw materials. Very clear and homogeneous solution is obtained in order to have complete mixing at the atomic level. So what we have to, why we have to mix these solutions, chemicals? Because we have to intermix all the chemicals at the atomic level. That is why we are mixing those. Now please go to the next slide. Now this is the schematic shown for the sol gel method. Here nickel nitrate is taken, iron nitrate is taken, and citric acid is taken. So if we are thinking about only nickel ferrite, oxygen will be coming from air. So these three chemicals will be there. Then we have to dissolve and then stir and mix it here at 70 or 80 degrees Celsius. This temperature is not fixed. Sometimes it may take more. We have to heat at more temperature depending on chemical selected. Then here, what will happen after heating this? The slow H2O will be evaporated at 85 degrees Celsius. After that, we can increase temperature and more water will be heated and evaporated to transform that liquid for the gel, and it will be converted into a gel material. And once that liquid is transformed to gel material, we have to keep this beaker in the we can say heating mantle. So the fourth step is shown there as a heating mantle in which beaker is kept, and it is set at 120 degrees Celsius. So what will happen? The volatile species and water molecules will start to burn, and here we are seeing some smoke here at the top of the beaker, and we'll get at bottom the you can say nanoparticles of the expected material. So here we are getting nanoparticles, but our nanoparticles may not be at the expected level in crystalline form. So after that, we have to examine that with different techniques. So this is called synthesis procedure of nanoparticles by sol gel route. Please go, sir, to the next slide. And this is the flow chart shown here for synthesis, how steps are involved here. Metal nitrates, citric acids, then it will be transformed to solution, then mixing and stirring, then sol will be formed, or it's called solution. Then after water bath heating, water will be evaporated and then polymeric gel will be formed. Then that polymeric gel will be further taken for drying and chairing, so that major part, which is volatile species and polymeric species, will be burned, and then it is pulverized again further in the oven, and then after that the raw nanoparticles will be taken for calcination. So these steps are mentioned here, and their time period of different parameters, temperature, then any process timing is given here. Please, sir, next slide. Yes. After that, the resulted material was crushed and charring has been carried out around 140 to 150 to remove, you can say, water molecules as well as the solid polymers. And only pure metallic particles will be remain. And then the resulted material was heated at 220 Celsius to remove further organic compounds contents, if any. And after that, it is taken for calcination at 400 to 800 Celsius if needed. Even at 300 Celsius, particles can be obtained in crystalline form. But depending on material and depending on expected crystalline structure, the calcinating temperature can be decided, and so that the raw material can be taken at that temperature. So in this way, nanoparticles can be formed. Please go to the next slide. Okay, and after that, one can examine its crystalline nature from the X-ray diffraction methods, from the obtained peaks and their corresponding intensity and the angle of diffraction. One can uh, correlate their X-ray diffraction pattern with the standard one and proceed to decide whether their material is formed or not. So X-ray diffraction technique is very important in the field of material science, which is first technique to decide the material whether it is crystalline or not, and depending on that we can decide whether we have to proceed for further steps or not. Okay, so please go ahead. Also, in addition to X-ray diffraction technique, we can uh, investigate our material for its morphology, and we can also determine the particle size or grain size, and comment about the surface morphology. So the scanning electron microscopy is a very good technique. Further, one can go for transmission electron microscopy also. So the surface morphology studies were carried out by can be carried out by scanning electron microscope, and we can ensure our material whether it is nanomaterial or not. So it is observed that the nanoparticles are almost of the spherical size in this presented images, and we can say that the monodispersed particles are produced in this third image. The average particle size also can be found out uh, using the data in ACM provided. Next slide. One more technique, very important technique and interesting technique is there, which is transmission electron microscopic study, where the electron beam is directly diverted towards the nanomaterials and transmitted through that, so that we can get very surprising data. In first figure, you can see very monodispersed particles are there. And if suppose we focus an electron beam on one particle only and transmit through that, then we can get very surprising picture. We call it as a high resolution transmission electron microscopy images, or selected area electron diffraction pattern, where we can get lower two images. So in lower first image, we are getting fringes, which is nothing but the diffraction pattern. And in next image, next lower image, that is selected area electron diffraction pattern, where we are getting circular fringes or circles of some, you can say, pattern, some pattern in circular. So those circles are corresponding to some planes, diffracting planes or diffraction planes, and as we have indexed X-ray diffraction peaks, similarly we can index these diffraction rings, and we can correlate the diffraction pattern in transmission electron microscopy with the X-ray diffraction, and we can confirm about our material, what type of material that is. Okay, so in this way, this technique together play very important role of scanning electron microscopy as well as X-ray diffraction, because here we can take images as well as diffraction patterns, and in one case also means only in one technique we can tell about surface morphology as well as diffraction of the material. Okay, so please go to the next slide. Yeah, now this basic methodologies and characterization techniques are over. Now the important part of my presentation is still left, and that is third slide, and which will end our presentation. So sir, please share the third presentation. So now I will present the third part of this presentation, that is impact of nanomaterials and emerging advances in nanotechnology and challenges. Please sir, go to next slide. Uh, okay. In the introduction, we know numerous technologies are advancing at an unimaginable rate, and it is not possible to cover all of them during the course of this presentation. So very few points are mentioned here. This presentation will focus mainly on intelligent sensors and wireless sensor networks, intelligent cars and their smart highways, then telehealth, or it is also called as wireless healthcare, then micro electromechanical systems, which is in brief called MEMS. Also, in the same line, we can mention nano electromechanical systems, which can be considered as NEMS in brief. Then nanotechnology, clean technology, robotics, and automation. That means nanotechnology is involved in all these fields that we have to see. So this slide will be, in brief, it is a roadmap of the technological development due to nano materials and nanotechnology. Sir, go to next slide. Yes. The first point, that is intelligent sensors and wireless sensor networks and opportunities in this field. Now see, under intelligent sensors and wireless sensors, what we can see, these are the fields: medical instrumentation, factory and office automation, automotive and transportation, telecommunication, and structural fatigue monitoring. That means if you look at all these fields, these are very different fields. In medical instrumentation, we can now, if you see, there are several sensors working in the field of medical instrumentation, and all these sensors are now became advanced because of the nanotechnology. And we can insert some sensors in human body to check for various diagnoses. We can insert micro cameras in the human body, and we can sense their various ingredients of blood, and doctors can diagnose what is happening there. So in this way, we can say that intelligent sensors are introduced in medical instrumentation. Also in factory and offices, office automation, sensors are working. We know in automotive and transportation field also, on road we can see there are several RFID sensors are there, uh, which are used to locate and check the uh, means any, we can say, abnormal things are happening on the road, that can be also monitored. Also in telecommunications, sensors, whether direct sensors are used or wireless sensors are also used. And in structural fatigue monitoring, that means, now what is the structural fatigue monitoring? In material, if suppose there are flaws are there or some defects are there, then those fatigues can be identified in the industry to produce fatigue free or flaw free materials for technical purposes. So there also sensors are working to avoid that fatigues. Please go to the next slide. Again, under the intelligent sensors and wireless sensors, now we can come here, the typical examples in cell phones and mobile networking, nanotechnology is involved, and multi-criterion, multi-path robotics also it is involved. Then bridges and structural monitoring, seismic measurements and simulations. In simulations also, uh, the nanotechnology is involved. Then wide range motion tracking system for augmented reality applications. This nanotechnology is useful, or sensors indirectly. Directly, we can say sensors are working, nano sensors are working. Then gait analysis for athletics, neurological exams, knee replacement, and cardiovascular health. In these fields also, the sensors, nano sensors are very, very useful to give information from those parts to the doctors. Then hand gesture recognition with acceleration sensing law in medical virtual reality, and surgery didactics and training applications are also involved with the intelligent sensors and wireless sensors. In machinery operations monitoring system, these sensors are, because robotics and whatever machineries are there, all those are controlled with the help of intelligent sensors and wireless sensors. Now these days, we know there are, we can say, clutchless cars are there, or automatic cars are there, isn't it? Where in some cars the clutch is removed, in some cars clutch as well as gears are removed, and cars are only now dependent on only acceleration and gear, we can say brake. Only brakes and accelerators are used now these days in automatic cars, where the role of clutch and gear changing is done by sensors. And what are those sensors? Those are intelligent sensors, and the also wireless sensors are there. So please go to the next slide. Again, monitoring and control of refrigeration in the grocery stores. Now these days, again, you know that our fan in the home, at our home, can be uh, switched off with the remote, isn't it? And we can say that it is a wireless sensor where power can be cut automatically with the remote and our fan can be switched off. Now, those fans are available in market. Then impact measuring for transit audio trail of cargo in freight industry. Also, these sensors are used in oil field pipeline equipment, continuous unattended health monitoring, measurement while drilling, surveying systems. Also, inertial navigation, global position system for control feedback in driverless agricultural equipment also involved. Also, these sensors are involved in drive through automobile service stations, check fluids and servicing needs while refueling or washing vehicles. So, in all fields, these smart sensors or wireless sensors are involved. Please, sir, go to the next slide. Then, in Indian car, just now I told you, safety critical systems, then electronic stability control, rollover prevention, then autonomous predictive cruise control also there. Now, cruise control is also there. That means there is no need of using your accelerator also. See here. Now we have removed uh, gear. Then we have removed the clutch. Now there is addition to the uh, car, which is called cruise control. That means if suppose the roads are very ideal, then we can use cruise control and keep our vehicle at the same uh, speed without any accelerator. Okay, accelerator will be there, but there is no use of using accelerator. Then intelligent speed adaptation, same thing with the cruise control. Then lane change assist, child safety seats to prime airbag based on the child's weight. Then drowsy driver detection and prevention. That means if suppose a driver is becoming lazy or going to sleep, then the sensor will make driver aware to prevent from any kind of accident. Then drunk driver detection and prevention is also monitored by such sensors. Then integrated safety management is there. So now these days, driving is also becoming very safety and smart now these days. Please go to the next slide. Then now see, you can see intelligent car cloud boost highway capacity by 273 percentage. Okay, and the date is 2012, which is this data is given by IEEE Spectrum. So here the intelligent cars are rapidly increasing in percentage, which is mentioned in this slide. Please go to the next slide. Then telehealth, wireless healthcare monitoring. Now these days, this technique is becoming very famous. Now typical examples are wearable sensors for monitoring vital body signals, heart rate, blood pressure, blood sugar level, cholesterol levels, etc. And then wireless interface for data transport to PC, cell phone, doctor's office with real-time indication of any abnormal behavior and recommended action. Then kiosk with real-time capability to monitor vital body signs and interact with individual as well as doctor's office. Then provide real-time vital body signs information to coaches in deciding whether to leave a player in or pull him out, basketball or football, boxing and other endurance sports. That means here wireless healthcare is very important. So all parameters will be monitored with this devices, and then wirelessly monitor conditions of vehicles, tire pressure, engine heat, RPM to determine servicing schedule. That means, see here how technology is becoming smarter and smarter with these wireless sensors or intelligent sensors. Please, sir, next slide. Now, what is MEMS? Uh, Imagine a machine so small that it is imperceptible to the human eye. Okay, we cannot perceive it. So in that way, what in that condition, what to do? Imagine working machines with gears no bigger than a grain of pollen. So what can be done? It is not possible to monitor us manually. Then imagine these machines being batch fabricated tens of thousands at a time at a cost of only a few pennies each. Or imagine a realm where the world of design is turned upside down and the seemingly impossible suddenly becomes easy, a place where gravity and inertia are no longer important, but the effects of atomic forces and surface science dominate. That means, so what will happen at such micro or nano level, MEMS or NEMS will work, isn't it? And therefore, now these days, the materials are fabricated. Sir, please go to the next slide. And sir, please make me aware whether I am audible. Vivek sir, Vivek sir,
Sir, you are audible, sir.
am I audible? Okay, okay, thank you. MEMS, the engine of innovation and new economies. Now, these micro machines. Now, what are MEMS? It is micro electromechanical systems. So these micro machines, and these are working as a micro machine. So these micro machines have the potential to revolutionize the world the way integrated circuits did. That means it is commented by Linton Salman, uh, and he made this statement, very popular statement. So here, the micro machining technology has the potential to change the world in some very important ways, many of which are not possible to foresee at this time. In the same way that standard IC technology has so revolutionized our lives and economies. And this statement is made by Ray Tata, who was chairman and CEO of Analog Devices. Sir, please go to the next slide. Now, this MEMS technology creates integrated electromechanical systems that merge computing with sensing and actuation. See here, sir. This is very smart integration of electronics and sensors. So, what it says, it creates integrated electromechanical systems that merge computing with sensing and actuation. That means it is combination of, you can say, three processes, and mechanical components have dimensions in microns and numbers in millions. See here, that means we can handle several micro size objects with these properties together. So it uses materials and processes of semiconductor electronics, and their wide applications are mentioned below in commercial, industrial, and medical systems, in automobiles, wearable sensors to monitor vital biological functions, then cell phones, in printers, in GPS and navigation systems. Now these days, if we see at all these 5 6 fields, that is automobile, wearable sensors, cell phones, printers, GPS navigation, these are very, very important parts of our today's life. Now we can't live without these techniques, and these techniques are now enhanced with the sensors, intelligent sensors and wireless sensors, and then these are integrated together in MEMS and NEMS. So here the key characteristics are miniaturization, small size and weight, then multiplicity and microelectronics and small cost and high reliability. So these are the key specifications or key characteristics of this MEMS technology. Sir, please go ahead. Applications of MEMS: inertial measurements, automotive safety, aircraft navigation, then platform stabilization, then personal and vehicle navigation. These are very important now these days as our population is growing day by day. Uh, it is becoming that these technologies should be there to monitor these big mobs. Then next is distributed sensing and control, condition based maintenance, situational awareness, then miniature analytic instrumentation or instruments, then environmental monitoring, biomedical devices, and active structures. These can be also sensed or distributed. It is called distributed sensing. And then in the field of IT or information technology, mass data storage and display is very important now these days. So it is done by MEMS and NEMS. Please, sir, go to next slide. Then applications of MEMS in automotive. Uh, I don't know this full form. YAW sensors, gyroscopes. I think this is name given by some, maybe there is no any comment that. Okay. Then accelerometers, airbag sensors are there. We know in cars, these sensors are fixed to avoid the damage to the driver or passengers. Then in telecommunication, antenna stabilization, GPS navigation, wireless communication. In industry, factory automation, office automation, process control, and in medical field, blood analysis. Now these days, we know there is a uncertainty of life of human being is there, and so that blood analysis is very important. And now these days, blood analysis and DNA analysis is becoming very important, and it is very easy and uh, simple to monitor our blood, and doctor can make aware patients what care should be taken. Okay, and then virtual reality. So please, sir, go ahead. Nanotechnology. The one slide is ahead, I think. Please, sir, go back one slide. Okay, key elements of nanotechnology. There are few materials mentioned here. Buckyball is there, saucer ball shaped molecule of made of 60 carbon atoms, which is called buckyball. And are composite reinforcement and drug delivery. Very important applications are there, and this buckyball is playing very important role. Okay, I couldn't show that buckyball image, but if you Google it, you will be able to see that buckyball image. Then carbon nanotube, a sheet of graphite rolled into a tube, and applications are composite reinforcement, conductive wire, fuel cells, high resolution displays. Now these days, whatever displays we are seeing, those are because of the carbon nanotubes, because carbon nanotubes are conducting, and uh, those are available in nano form. And now resolution of screen is becoming day by day very good. So now these days we can uh, watch the screens at the 4K resolution, 8K resolution, and these 4K or 8K resolutions are very, very ideal, because if you see the real image, natural image, and see this image on the screen, or isn't it? Then you will feel that the image which is looking on the screen is very, very beautiful than the real one. So this is magic of this high resolution due to carbon nanotubes and nanotechnology. Then quantum dots, a semiconductor nanocrystal whose electrons show discrete energy levels and much like an atom. So applications of these are medical imaging, energy efficient light bulbs, and medical imaging is very important. I don't know how much you are familiar with this medical imaging. This medical imaging is very significant in medical field for doctors to diagnose the interior of human body, to decide what treatment should be given to the patient, and that is due to quantum dots of semiconductors. And nanocells, a nanoparticle composed of a silica core surrounded by a gold coating. Applications are medical imaging also, and the cancer therapy. See how important these nanoparticles are for us. Sir, please go ahead. We have still further 5-6 slides. This is image of the nanowire synthesis of carbon tube, you can say, or yeah, CNT. Please go ahead. Now, typical applications of nanotechnology, single electron transistors can be also prepared. So here uses a single electron to indicate whether it represents a 1 or a 0. That it is electronic language, you can say digital language, thereby greatly reducing the energy required to run a processor and limiting the heat levels generated during operation. See here now how smart these processors are becoming now. So due to single electron transistor, we call it as in brief SET. If we use such transistors, then it can process very nicely, and it can save the energy utilized for processor now these days. Then magnetic random access memory, MRAM, non-volatile electronic memory that is faster and uses less energy than conventional dynamic RAM. Then spintronics, spin-based electronics uses electron spin and its charge to represent binary ones and zeros. Also, spintronic technology can be used. Then quantum computing, unlike a conventional computer, it uses quantum mechanical properties of superposition and entanglement to perform operations on data, and will rely on probability. That is, in effect, it is highly likely that the answer is. Okay, so the quantum computing will run in parallel, performing many operations at once. And it is emerging very rapidly, it is coming. And there are now few institutes, they are offering degree in quantum computing now these days. Sir, please go ahead. Then typical applications of nanotechnology in continuation with that, quantum cryptography is there. It is based on traditional key-based crypt using unique properties of quantum mechanics to provide a secure key exchange. Okay, it is called cryptography. Then photonics crystal, nanocrystals that guide photons according to structural properties, and it is called photonic crystals. Okay, so every phenomena can be very smartly utilized to make our technology very smart. And others, under others, cell phones with longer battery life, smaller and more accuracy GPS, faster and smaller computers, smaller and more efficient memory, smart materials, fast and accurate DNA fingerprinting, medical diagnosis, and drug delivery, etc. are facilitated with nanotechnology. Uh, Please go ahead. translational applications of nanoscale multi-periodic systems, which is also called as, uh, in brief, in the next slides, brief, those small form is used, short form is used. So I will proceed for this. The NSF funded a multi-million dollar program based on a new approach to electronics cloud lead to tiny devices once considered fantasy. So here electromagnetic devices operate by passing an electric current through a wire and works extremely well in the large scale but fails in the small scale. Like water flowing through a pipe, as wire diameter decreases, so does amount of current flowing through it, limiting the ability to create and control electromagnetic energy. So in this way, nanowires can work. Uh, Please go ahead. So this TNMS seeks to solve this problem by taking advantage of multi-toroid materials, which use electric fields to intrin- intrinsically switch the magnetic state of a material, similar to switching a light bulb on and off. So uh, this school, that is the UCLA School of Engineering and Applied Sciences, got $35 million over 10 years grant for this research. And research in this field, narrow field, is uh, rapidly growing, which was reported by many researchers. So please, sir, go to next slide. Then clean technology, which is called also clean tech. Now, under clean technology, we can see alternate energy sources, which are solar energy, wind energy. Specifically in solar energy, we use nanotechnology to deposit materials in the form of thin film, and we advance or make the solar cells more and more advanced. So in this way, nanotechnology helps in the clean, as a clean technology. Then also nanoparticles or nano surfaces are used in fuel cells as electrode materials. Also, smart grids are emerged as a architecture or sensor software with the architecture, sensor softwares or middleware or interface. In these various forms, smart grids are now equipped. Then smart meters. Meters are also again made very advanced for monitoring and comparing and optimizing their mechanism. So in this way, uh, this is called the clean technology with the nanotechnology. Sir, please next slide. I think this was the last slide. Go to last. Okay, one more slide is there. Yeah, I think there are 2, 3 further slides. So here, robotics and automation is also facilitated with the sensors and actuators. Uh, Now these days we know robotics is nothing but it is integration of many engineering works, electronic engineers, then mechanical engineers, instrumentation engineers will work, and also computer engineers will work, and then robotics or robots are formed. Please go ahead. Then these are the typical applications under robotics: search and rescue, then search and destroy, fire detection and prevention, biological threat detection, and chemical split and threat detection. These are the functions coming under robot systems. Then medical instrumentation, assistive and rehabilitative applications are there. Then home automation and applications, factory and industrial automation is there. These are all fields facilitated with the sensors. Please go ahead. Next slide. I think further next. Okay. So this is just picture given here. In 1956, how was the world, and in 2012 or now these days, how we are playing with various technologies due to advancement in due to the advancement in technology, due to nano materials and nanotechnology. Please go ahead. I think there is a concluding slide. So technology will change our lives and the way we conduct our day-to-day activities are facilitated. Major technical breakthroughs will be interdisciplinary and occur at the fingers of classical disciplines, that is bioinfo nanotechnology. Then now these days, engineers, scientists, and technologists will need to be trained with depth as well as breadth for the further development. Learning to work in team will be of paramount importance, and verbal and written communication skills will be indispensable, and those are becoming smarter and smarter now these days. Cost effective and efficient manufacturing techniques and processes will play a pivotal role in determining whether a technology is merely a laboratory curiosity or whether it can be commercialized. That means our nano research should be fruitful. We should get some benefit from that. So the intention of this slide is to make aware the researchers who work in that way. Then customization is also very important now these days, as our country's population is increasing day by day. Then technology will affect our future in unimagined ways. So the last statement is made here. The best way to predict the future is to invent it. So here I think my slide is ending. Sir, go to the next slide. So thank you for your patience, and you listened me for entire session. Sir, my timing is also ending. Okay. Yeah. I don't. I would like to. I would like to hear questions from the participants, if any. Is there anybody who can ask, who will ask question or interested to ask any question? So there is no any hand raising, sir. Yes, in chat box I will reply. So thank you very much for your patience, great patience to listening me. This is for these 2 hours after lunch. The session will be very heavy. Okay, thank you, sir. I want to tell one thing that if suppose though there are some, these are the participants of this workshop, they can be in contact with me related to research. Uh, I'm very amateur in this field that I will be. I wish to collaborate and keep the research relations, isn't it? Yeah. So I have. Yes, yes. I will definitely share. Yeah. Yes, sir. I have shared it. Okay, sir. Thank you very much for this opportunity that I could deliver nicely at my level. I don't know how much fruitful it is. Okay. Uh, thank, thank you very much. Yes. Yes. Okay. Shall I leave now? Thank you.